In this video, we're going to take a look at 3 different cases where limits would fail to exist. Right? So the first case that we would have, first time thing that we see where a limit would not exist, is if our function f of x, it approaches a different number from the right-hand side of c as it approaches from the left-hand side of c. If it's approaching 2 different numbers, we would say that limit does not exist. Graphically, you could have something like this, where if this is our value c, as we approach from the left, it looks like it's getting closer to 1 value. But as we approach from the right, as we get closer to c, it's approaching a different value. So those 2 function values are not the same function value, and so we would say that limit does not exist. Another case where we would have a limit not existing is if our function f of x either increases or decreases without bound as x approaches c. If that is the case, then we would say that limit does not exist. When it's increasing or decreasing without bound, you might know these better as vertical asymptotes. And so graphically, you might have something like this. So if that's our value c, as we get closer and closer to c, we might have something like that. Right? You have this vertical asymptote right here. And so that limit would not exist. It's not settling in on a number. It's getting closer and closer to infinity, getting larger and larger, but infinity is not a number. Later on, we will sometimes write when it's approaching from both sides, they're both approaching positive infinity or both heading towards negative infinity. Eventually, we will write that as equals infinity, but even when we write something like equals infinity or equals negative infinity, we are really saying it does not exist, that limit does not exist, but here is how or why it does not exist, right? So we might write equals infinity, that's conveying that it does not exist. If f of x oscillates between 2 fixed values, then that limit would not exist as well. And so this is pretty tricky to show because I can only draw finitely many things. But if this is our value c, what you could have happen is you have some sort of, as you get closer and closer to c, it just starts to oscillate more and more wildly. And because it's oscillating more and more wildly, so the idea is if you zoom in, and the more you zoom in, there's just more and more oscillation. I can only draw finitely many oscillations. But if it oscillates infinitely many times, then we would say that limit does not exist as well. So those are the 3 cases where the limit would not exist, right? So it could approach it different numbers from either side. You could have an asymptote, a vertical asymptote on either side, or it oscillates between 2 fixed values as x approaches c. Now you can have wild oscillation between 2 values that are not fixed, where it gets closer and closer. It is possible to have wild oscillation that settles down. The size of that wave heads towards 0. You could actually settle in on a number, but this specifically says when we have 2 fixed values. So if they're not fixed, then we would have to do more investigation. All right. In our next video, we are going to look at a more formalized definition of the limit. We will talk to you then.